And welcome back. If you remember in the last video, we had two of these 280 amp hour cells unboxed. As you can see from the pile of empty boxes here, and from what's stretched across our workbench, we currently have all the cells unboxed at this point. All the cells look good with the exception of two. And you'll see these two here marked B1 and B2. You'll see that this cell here took a little hit on the corner. Now it's not piercing into the cell or into the cell, but it was able to deform the casing. So it's not all that bad, but you can see when I put my thumb up here that it kind of does rest in quite a bit. The second cell was a little bit more worse for wear. And you can kind of see with the bottom corner here that it took a pretty good size hit in shipment. And I have alerted the manufacturer to this to kind of see how they want to handle it. And they did ask me to give internal resistance readings as well as voltage readings of the cell. They confirmed there was no electrolyte currently leaking out of this cell, and there isn't. But waiting to kind of see how they want to handle it. But these cells will not be used in a pack. I just don't trust. I mean, this one probably wouldn't be too bad, but definitely this one with the dented corner in it, I wouldn't trust it to be in a pack with other cells. But with that being said, we did order 4 extra of these. So if I can add that as a tip, make sure that when you order your cells, order a few extra. So in the event of something like this, if you do get some that sustain shipping damage, then you're not waiting for replacement cells before you can continue building your pack. And one thing I forgot to mention at the beginning of this, I will like to mention now, is that you'll see me wearing gloves, especially when I'm dealing with anything with these batteries. Wear a pair of gloves, wear a pair of safety glasses. It's really quick, really cheap insurance. Typically, you only get one OEM issued pair of hands and fingers and set of eyeballs, and preferably you want to keep it that way. So again, put on a pair of gloves and safety glasses before you deal with any type of battery. With that being said, again, these 2 batteries will kind of sit over here to the side. That still leaves us 2 spares and 2 banks of 16 each. All the other cells ended up working out with no issue at all. We did number these cells, as you can see, just for ease of keeping track of where we are with our measurements and our charging cycles. With that being said, we did do a voltage check on it, and all the cells are showing 3.29 volts. Not that using voltage is a good indicator for LiPo 4 cells, but they all are at least at that state of voltage at this point in time. Got to remember, with your LiPo 4 curve, the way your charging and discharge curve looks, you can have a cell sitting at 3.2 volts and be fully charged, and a cell resting at 3.2 volts and have absolutely no capacity left in it. Because as LiPo 4 cells reach their end state of charge, they'll actually settle back down to that 3.2 volt mark. And also when you discharge it, it'll fall below that 3.2, but as you take the load off and the battery comes back up in the resting, it'll actually come back up to that resting voltage of 3.2 volts, which is why voltage is not really a good indicator for a state of charge for LiPo 4. With that being said, what came with each battery was the hardware that you see here. It is all stainless steel. You'll see that they came with a bag of these studs, Allen-based studs, rather than the little small bolts that you see some cells come with. So I'm really happy to see that these came with mounting screw studs that you see here, or these Allen-based set screws, as sometimes they're also called. They also came with the flat washers, as well as the lock washers, See if I can get that back in the camera here. And as well as the flanged serrated nuts that you see here. Again, all stainless steel. These bus bars, we got 1 bus bar per battery. So in our order, we ended up with 36 bus bars, which in our case will do what we needed to do, because we'll have 2 banks of 16. One thing to keep in mind about these batteries is that since you are this particular manufacturer, this shipment, is that if you're only going to get 1 bus bar per battery, if you're looking to do things such as 2S, 1P, or 2P, 1S, things of that nature, just different types of battery configuration, you may have to order extra of these bus bars. But for doing what we need to do, these amount of bus bars will work out just fine. So there we go. Reasonably thick bus bar. And I don't know how well that'll show up on the camera here, but you can see I did scratch one of these, and you can see that there is copper underneath that. So that does make me extremely happy that those are copper bus bars. And we used this meter to check the internal resistance of each cell. And this meter comes back at about 2.2 to 2.5 milliohms per cell. I also verified that using the internal resistance check on the iCharger. Again, I can't say how accurate or inaccurate this thing may be. It is a rather cheap internal resistance checker that I just got off Amazon. But even with it maybe an inaccurate, it was really close to what the iCharger was showing for the internal resistance, as well as it's still a good tool to use to baseline all the cells and verify that they were within 0.1, 0.01 to 0.02 milliohms of each cell. So our plan for these cells, as you can see here, just as an example, we've got 1 iCharger X8. We'll have 2 of these at a time running off an HP power supply. And we're going to charge each cell up individually. Once that's complete and all 16 have been charged individually, we'll put them in parallel. We'll let them sit for a bit, and then we'll do another charge cycle with all 16 in parallel. Once that is completed, then we'll disassemble the pack and we'll put it into a 16S configuration. And we'll do the same thing with the other 16 cell bank that you see here. Now, others and other videos, and there are various different ways of being able to top balance these cells. A lot of individuals will just put them in parallel right away, let them set to each their own. Do with your cells as you feel more comfortable with. But I've chosen to just go ahead and try to cut down a little bit of the time that it takes to top balance these by individually charging each one. Like I said, put them in parallel, let them sit, top balance again as one big 16 16P pack. Once that's done, break it apart and make it a 16S pack. And just an example of, you can see that we've got an iCharger X8 hooked up to one of the cells here. And again, we're just running off a HP power supply. And we've already pre-wired another XT60 connector for our second iCharger. And that is it for this update. Just want to let you know that things are progressing, and we're kind of doing these as we can fit time into this to get this accomplished. I know you're excited to see it as much as we are excited to get these into our battery bank in our house and attached to our solar system. As summer is starting to get here, it's starting to get hot, and along with the household air conditioning, we want to run the air conditioner in that mini split, but we want to be able to have enough capacity where we can at least run part of the house in the evening hours when there's no sun off battery, and then recover that charge as well as run the house off solar during the day. And you may have seen our previous video in which we just got a new solar stand, ground mount solar stand installed with an additional 18 100-watt panels. And we'll have more videos on that soon as we get that tied into our charge controller. Other than that, that is the update for now, but thank you for watching.